You sit down, open your laptop, and drag a window across the screen. It feels like a single, solid object, but that smooth piece of digital glass is a very convincing illusion, hiding a chaotic, continuously grinding machine. Building that illusion used to be incredibly difficult. In the mid-1990s, if you wanted to program a graphical user interface, you were entirely at the mercy of the machine sitting on the desk. Early Java developers used a tool called the Abstract Window Toolkit, or AWT, released in 1995. AWT was what programmers call heavyweight. It couldn't draw its own graphics. Instead, it had to constantly ask the host computer's operating system to draw every single element on the screen. Because Windows, Mac, and Linux all interpreted those drawing requests differently, a button coded perfectly on a PC might end up wildly misaligned or completely broken on a Mac. It was a logistical nightmare for developers trying to release stable software. The solution arrived in 1998 with Java Swing. Think of Swing as a standardized box of digital Lego bricks, designed specifically to bypass the platform wars entirely. Instead of begging the operating system to render a drop-down menu or a scroll bar, Swing was written completely in Java. It took full control and drew its own interface directly onto the screen. For developers, this meant they could write the code for an application exactly once. Whether the user opened it on a Windows 98 machine or a brand new iMac, the interface was guaranteed to look exactly the same. Let's look at how this is actually constructed. This image shows a basic desktop calculator being built inside the NetBeans coding environment. To the user, this looks like a flat surface, but pulled into 3D space, it's stacked layers. Each piece is a J component: text fields, buttons, independent blocks. Because Swing is lightweight, Java paints these itself pixel by pixel, ignoring the host's graphics engine. The final application is an interactive mosaic, dozens of self-drawn components arranged carefully across a blank canvas. If these components are just separate floating blocks, what keeps them in order? For instance, if a user stretches the window all the way across their screen, how do the buttons know exactly where to go? The answer is layout managers, invisible architectural grids dictating exactly where components sit. With a grid layout, the grid forces calculator buttons into an equal matrix, stretching them uniformly as the window resizes. Other managers solve different spatial problems. Card layout stacks entire interface panels directly over one another. As this image of overlapping playing cards illustrates, this is the exact logic used to create the clickable tabs you see in software preference menus. By handling spatial math in the background, layout managers free developers from calculating strict pixel coordinates, allowing the interface to adapt seamlessly to any screen size. There is one final layer to this machine. To prevent the application from collapsing under its own complexity, Swing uses an organizational structure called MVC, or Model View Controller. MVC creates a strict boundary between what the user sees and what the computer calculates. It separates the view, the physical button, from the model, the mathematical data. When clicked, the button merely fires a signal down the wire, instructing the logic to update itself. Swing actively isolates the visual presentation from the raw data processing, keeping the application's code modular and stable. Today, the original era of Swing is largely behind us. Oracle, the current steward of Java, is no longer actively updating the toolkit. In 2008, it was succeeded by JavaFX, a newer library explicitly built to handle modern hardware advancements, from high-definition touchscreens to handheld mobile devices. Swing's lasting contribution was a structural philosophy, the idea of building user interfaces out of independent, reusable visual components managed by intelligent layout systems. By proving that complex interfaces could be broken down into discrete, manageable parts, Swing provided a roadmap for creating consistent user experiences across different types of hardware. The concept of building apps from independent, reusable blocks and managing them with dynamic layout rules is the same architecture found in modern web frameworks like React and mobile operating systems. When you interact with a responsive website or a smartphone app today, you are using a digital grammar that matured inside the Java Swing toolkit.